What is musical density? If you look in the dictionary, you'll find a definition of the following kind: the quantity of something per unit measure, especially per unit length, area, or volume. So a measure of density requires the comparison of a number of things constrained within units of space. The density of information is a powerful factor in our appreciation and comprehension of language and music. In music, the units of density are time units, and the things measured in relation to the time units might be any of the following: attacks, voices, timbres, registers, intensity of volumes and textures and information. The density of attacks, that is, events per unit of time, includes any type of sounding event from a drum hit to a chord to the number of words in the vocal part. Polyphonic music depends on the varying number of simultaneous voices. A fugue usually starts with a single voice, which is joined gradually by others. The music becomes more phonically dense. Clearly, as more voices enter the music, so the degree of timbral richness will increase. The symphony orchestra offers degrees of timbral density relative to the number of players. The emphasis placed on a particular range, bass, middle, or treble, determines a density of register. Likewise, contrast in dynamics has the quality of density. This is most extreme in electronic music. For example, LFO modulation applied to volume creates the tremolo effect. So textural density, then, is a compound of these qualities. Between pages 1226 and 1247, Schillinger introduces an idea he refers to as textural density. This is one of the most challenging discussions in the Schillinger system, largely written in Schillinger's special system of algebraic notation and accompanied by very few musical examples. It is, however, unusual and far-reaching in its concept and deserves clarification. The density of music changes very rapidly. An orchestral work contains numerous instrumental combinations, ranging from solo to tutti. This might be described as the density of orchestration. Schillinger suggests that there's another kind of density, one of texture, produced by patterns of arpeggios and harmonies, which is also fundamental to musical flow. The general theory of harmony is based on the idea that a score can be made up of independent but coordinated harmonic layers or strata. These collectively are referred to as sigma. One can imagine a sigma as being something like a geological diagram showing a cross-section of the Earth's crust. Textural density depends on varying the number of strata in a score from one moment to the next. Alternatively, imagine a sequence of slides in which the same three-story building appears at first complete, and then with its ground and top floors missing, and finally with the top and bottom floors intact, but without the middle story. For the house, substitute sigma. For the floor levels, substitute a harmonic strata. A sequence of sigmas, such as this, will be referred to as a density group. Once a density group has been composed, its variations can be generated by rotation. The slide shows a three-element density group and two variants produced by rotation in a clockwise direction. Inactivity in one or other stratum is shown as a white rectangle, while a black rectangle represents activity. The first group starts with sigma 1, which consists of three active strata. It's followed by sigma 2 and sigma 3, which exhibit varying degrees of activity. A density group is subject to rotational variation in two directions simultaneously: rotation around the vertical and horizontal axis of a graph. When textures are rotated vertically, it's important to ensure that the harmony belonging to any stratum doesn't change its position, which would radically alter the harmonic structure of the entire score. Three vertical permutations of the original density group, first seen in the previous slide, are shown now. The different textures and forms of arpeggiation rotate vertically, moving upwards by one place at a time, as indicated by the arrows. Each stratum is labelled to indicate a hypothetical form of texture. Harmony 1, H, or Melody 1, M1, or Melody 2, M2. The two melodic types might be different patterns of arpeggiation, while Harmony 1 might be a type of harmonic accompaniment using block chords. Here's a partial realization in music notation of the scheme of density groups we've seen thus far. All the patterns are extremely simple, deliberately so in order that this illustration is clear. Now I've developed the scheme just a little bit more. This time there are 3 different sigmas, each with 3 strata, forming a harmonic progression. And you can see I've tried to individuate the melodic and harmonic strands just a little bit more. If I take this scheme one step further and assign instruments and a little bit of artistic license, we get this.